This is an overview of our model.
Hello, my name is Lydia, and I'm going to show you a school building in Lego. We have 5 motors and 3 sensors. Over here we have an automatic door with one motor, and an elevator for the disabled with 1 motor and 1 tilt sensor. Bidirectional windmills and a sun tracking solar panel, a water collector and filtering system, a trash classifier with 1 sensor and 1 motor, and an observatory.
Here is a demonstration of the automatic sliding door we have at the front of our model. The sliding door opens when a motion sensor detects a coming person or thing. For the students in the school, we designed an automatic door with a sensor to detect if anyone is coming. If the sensor detects correctly, the door will automatically open. Here is a demo. It's opening. Now it is closing. Here's our elevator in the model. A tilt sensor over here is used to control the up or down movement. We designed an elevator for the disabled people, like people in wheelchairs who cannot climb up the stairs. These elevators are controlled by a tilt sensor, as shown here, to control the up or down movement of the cart. Here is a demo. See the elevators going up. Now it is going down. Finally, we have a trash classifier. Assume the recyclable and non-recyclable trash are packed in white and black bags. The remote sensor puts different colored bags or Legos in different places. The school produces a lot of trash. I designed this trash classifier to sort out the recyclable or non-recyclable trash. Pretend this is a non-recyclable trash in a black bag. A motion sensor which detects different numbers to different colors is used to detect if the trash is recyclable, not black or white. Here is the demo. See, the non-recyclable trash just went over there. Now pretend this is recyclable trash in a white bag. It just went over here. Thank you.
Thank you, Olivia. Does anybody if anybody has any more questions, you can leave them in chat now.
And can you not let them autonomous?
Okay, we're gonna go ahead and move on to CAD. So John, you can go ahead and start.
Okay, sorry, I was muted. I guess I'll just jump right into the demo then.
Okay.
Okay, so, okay. So this is, I'm going to be CADing like a tiny recycling bin. So this is my process then.
Oh my God, stop.
John,
There's stop
can you
annotating.
enable annotation?
Oh, okay. Wait. Okay. So it starts with a sketch, and the idea of a sketch is that it's supposed to capture as much of the design intent as possible.
You need to clear also.
Clear the annotations. It's still there.
Is it here?
No.
If you click on like,
Okay.
okay, yeah.
So it starts with a sketch, and the idea of a sketch is that's supposed to capture like as much of the design intent as possible. So a trash can, or a recycling bin, if you think about it, the main like part that's important about it is actually just like the top view, like the overall shape, kind of. And that's a rectangle here. So I'm going to do it at the origin, so it's just like a nice place to start. And then I have a rectangle, and you want to dimension that using here. Dimension here, which I just use the shortcut for D. Yeah, and you can say like this is like something, any number. I should say 1.5 by like 1.2, and you can see that kind of looks right. So next, we'll do the second most important sketch, which in this case it's side profile. And so start with just some lines, and then the lines have constraints, so they're up here. And I think we want to keep it like so it's easily modifiable. So we want to have this entire thing as like one width. So I'm going to create these lines here. Oh, oops, that's not supposed to be perpendicular here. I'm going to select all these lines and make them constructions, and also make them equal. So now all the thicknesses change at the same time. I'm going to set this to what? I want to say like 0.8. Well, that looks. Yeah, that looks about right. And then I'm going to project this with the project tool by just pressing P, or can do project include here, and that brings this line to this new sketch. So now I can link these two sketches together by saying this is right above the edge of the sketch. So now we have more constraints on it, and then I'm going to make another dimension because we need to dimension the angle of this. So I just say something like 0.3, and okay. Well, it's not fully constrained yet because we have things that are still being able to drag around. So the new dimension, this one, which is the overhang, just say 0.02. Oh, yeah, I forgot to mention the height too. Mention this here. Say that's too small, say 0.05, and just gonna be 0.1. And then you can see from the sketch, everything looks about right. So next, I'll create another sketch, like on the same plane, and I'll just double click this and project it. And the idea is that we can use this extrude, which is, I believe it's, oh, you can't see it in the sketch view. It's the sweep, which follow the path. And that allows us to make this a 3D shape that's like symmetrical and like all the sides basically. So I'll go edit that sketch. And then, yeah. So I'll do the same thing, except this time, because I guess I'll show you. The sweep doesn't actually work with this line. Because this line is not actually touching this thing. So we have to make this sketch where we just say this will, oh, say this will be projected onto it. And just you just want to make this this box, which is the same, like it's just like similar to the bigger box, but like it's touching the thing, the sketch. So in order to do that, we do use these two and set them equal. And now we can use the sweep tool. And you want to make it a new component, because that's usually just easier to work with components. Now we have the basic shape. Oh, now we can do the basic, like do more like add-on and stuff. So you create a sketch, and you want to do on this plane, and we just do like text. So here, say the text as recycling. And want to make it smaller. Now we want to constrain this this text so that it's like we have it in one place and it never changes unless we want it to. So it's kind of hard to mention text because it's like it's kind of like more of an aesthetic thing. But I'll just mention this as like 0.15, and I'll just keep it what it is. So that way this box always contains the same text. Actually, I'll make this a bit bigger. Now that's our box, and we can just like lock this here, or we can specify like we want it in the middle of everything. So connect midpoint to midpoint. And we see that's a straight line. And then we want it to be equidistant from all the edges. So we put some lines there. And want to make these equal. Oh. I just had trouble finding out that. Okay. I guess I had trouble there because these two, I think they would probably be redundant if I had them set to be equal. Well, now we have this sketch fully constrained. Now I can extrude this text. I'll just extrude it out. Let's just say something like 0.02. And then finally, we want to fillet the edges. And that just makes everything round. So unfortunately, you have to select all of these edges manually. I'm going to select. Usually, you can just get like what looks about right, and then yeah, put it something memorable, I guess. And then we want the edges here to be slightly smaller fillets, like this much. And because we already did fillets, we don't have to click as many lines, which is helpful. Now this would probably be like 0.02. Let's see that. That's a bit too small. 3.5. Yeah. Now we have our recycling bin. And the benefit of doing a recycling bin this way is that, like, say we printed this recycling bin and it comes back like, oh, it broke really easily. Well, then it's pretty easy. We just find a sketch, edit it. Oops, it's loading. Okay. And I just say like, this is, instead of 0.1, we say 0.15 or something. And just finish sketch. Now everything's thicker. Okay.
Okay, now we're going to move on to robocode. So Byron can go ahead and share.
Chat was getting too spammy, so I'm pretty sure we made actually Melody, can you just make chat like host only?
Yeah,
And then if they have questions, they can like send it to you and you can get it to me.
okay.
Okay. Anyways, hey guys, welcome to Robocode. I'm gonna share my screen. Hey guys. Yeah, welcome to this session of Robocode. Yeah, Eclipse. This is a reminder to use Eclipse. I was actually using Eclipse to code this. I know normally when I show you guys the code, I do it through like the built-in robot editor. But some I use Eclipse because it's a lot easier when we're doing complex code. Yeah, and today's lesson is pretty complex. So you guys have to pay attention and make sure if you have questions, just ask in chat. Yeah. Because today we're doing pattern matching. Okay. So you might have last week you guys might have seen my robot and I had to go early, so I didn't have much chance to talk about it. But one thing I did mention is that I used a pattern matching gun. So I'm gonna show you guys how to do that today and kind of like a simplified version of my robot's gun. And yeah, it's gonna be really cool. So robots often move according to a loop, right? So let's open up like, for example, my first robot. Yeah, so all it does is it moves ahead and then it moves back and it turns its gun in a loop. It just does that over and over and over. And a lot of robots do that. They just put their movement in a while true loop and they repeat the same thing. That's but a lot of robots do that in different ways. Some robots move in a circle, some robots like go ahead and back. So you can't always predict it. Predict what robot you're facing and use one type of targeting thing for everybody. So we can use pattern matching. So what pattern matching does is it stores the data about the scanned robot's movements into a database, and then it loops over the database to try to find patterns and predict where the robot's going to be next. Yeah, so again, it's going to be pretty hard to understand. So if you have any questions, don't hesitate to ask in chat. All right, so we're just gonna be going over some code step by step, and I'm first gonna show you guys this like kind of basic concept, and some things are inaccurate. We'll fill them in later. Okay, yeah. So some things are gonna be kind of inaccurate, but we're just gonna make it more accurate later. This is just the basic concept. So let's say that we're like my first robot, right? I we keep going forward, back, left, and then we go forward 400, back 400. So we change. We have this pattern, right? So whenever we scan this robot, our on-scan robot event, we're going to store all this data into like a list. So, and then when it's time to fire, we look at these recent two movements, or for it's a lot, usually a lot more than two, but we'll just say it's two for now. So hey, we see this robot recently went forward 400 and then back 400. So we look through this data to see if we have a match for this. So we're looking through, we're looking through, we're looking through. Oh, we found a match. Forward 400, back 400, right? So now we assume the robot will continue on like this. So we assume it's not always going to be right, but we say that the theoretical next move, it's going to turn left 45 degrees. So then we take the robot's current location uh, in relation to our robot. We simulate it turning left 45 degrees, and then we can just fire at that position. And if your robot does have a loop like this will almost always hit at the exact same place, no matter what is inside that loop. Yeah. So this is a pretty powerful technique. And we're just gonna walk through it step by step. So first, we're gonna have to actually store the code. So storing data. So to store data, we're gonna use something called a string buffer. A string buffer is like a string. If you don't know, a string is like a list of text. So I put in and they're encapsulated in quotation marks. So if I do like, hello, this is a string. A string buffer is kind of like a string, except you can edit and search specific positions in the string. And there's
Why
a
are
lot
there
of
so
functions.
many zeros?
Okay, so first off, if you have questions, don't ask them over voice. Just type them in text to Melody, and she'll get them to me. But to answer your question, there's a lot of zeros in here because it's like the default. Uh, it's a default. We put these in here as placeholder values so that at the very beginning, when we don't have any data yet, our robot doesn't like break. Because if we try to search this when it doesn't have anything, right? So let's say if we try to search this, it's gonna return an error because you can't search something that's empty. So we need to put in some placeholder values at first. Yeah. So you can see I commented initialize with a few placeholders. And then when we scan the robot, we get some information, right? We call the distance is the distance between our robot and their robot, and then absolute bearing. That's like, uh, if you guys don't know, bearing is like the angle of the robot, like how far it's tilted, and we calculate absolute bearing, which is the angle of the robot in relationship to the map. So get bearing radians returns like the angle of the enemy robot to us, and get heading radians returns our angle. So when we add them together, we can combine them to make the enemy's kind of heading, which angle the enemy is pointing. Yeah. And then after that, we can insert this. We can insert all this information into our history, our string buffer, right? So we put this in. We actually convert this to a character. So something Java can do is you can convert a number to like an ASCII character. And that just makes it like a one character representation. It saves a lot of space, but the computer can still read it fine. If we look at the data, we'll just see like a bunch of random characters. We won't see anything, but like the computer can read it fine, and it just saves space and makes it faster. Anyways, we use the sine function. Don't worry if you don't know trigonometry. You can see like we're putting it in sine for now, but we're gonna like kind of unpack it later, and we're gonna make it back to normal. So you guys don't really have to worry about the sine. Just know that it's there, and I'll be posting out the code, and I'll probably be giving it an email later on if you guys want to look at it. So, anyways, we put in data about the enemy's angle and its velocity, what speed it's moving, right? So, and that's actually all we need to know to predict where it's going to go next. because if we know the angle and the velocity, then we can just point the robot at a certain angle and then simulate it going forward by its velocity, right? Because a robot can usually only go forward and backwards. Yeah, well, not usually. It can only go forward and backwards. So we're going to insert data on heading and velocity. Perfect. All right. So let's update our concept graphic. So instead of just vaguely like we're storing the data, we're actually storing it in a string buffer, right? So for after each turn, we're going to do history.insert, and we're going to put all this data into our big string buffer, which is like a list of all the robot's movements. Yeah. So I'm gonna show you guys. Yeah, this is the actual code part. So this is my complete robot. It's just called pattern bot. And usually I type out the code here, but since there's like a lot of moving parts, I decided it would be better to just type out the entire thing beforehand and just show you guys. So here you can see in natural code, this is basically the exact same. We have our history, we declare it. One important thing is we have to declare it outside of the method. We can't declare our string buffer inside the method, because if we do that, then every time we scan our robot, we're going to be creating a new string buffer, right? So it's a history is new string buffer. So it's basically going to reset every time we scan a robot, and we don't want that to happen, obviously, because otherwise, you're not going to get any long-term data. You're only going to get like one data point. So yeah, you need to declare outside. Anyways. Now we have to find patterns. So after we've stored the data in, we need to search through it to find a pattern similar to recent movements. So this code is a bit more complex, so I'm just going to break it down. First, we start with a variable integer math length equals 30. So this represents the number of turns we want to search. So for example, we go back to our concept. So if our match length was 2, we would be searching, like we did an example, right? We would be searching for these past 2, forward and back. We would be looking for just forward and back. But if our match length was 5, we would be searching for this whole sequence, forward, back, left, forward, forward, and I would have to match this exact amount. So obviously, a match length of 30 is like bigger than this entire thing. But a turn in robocode is really fast. So you're gonna quickly get a lot of this data. So 30 is actually a pretty reasonable match length. Anyways, index. So we declare a variable called index that's going to represent a spot in our history that contains the best match, right? So let's say forward, we find our match over here. So our index is going to be the location of this left move in our code. Yeah. So, and then this is the big part. There's a lot to unpack in this one line of code. So we do while index is equal to history to string index of. All right, so let's go over kind of these functions. And to help, if you guys don't know what some functions do, what you can actually do is search up Java string buffer. Yeah? Yes? Hello? Okay, never mind. Yeah, so what you can do is you can search up string buffer, right? And here it'll return all the methods that string buffer has. And here you can find what all these things are doing. So let's look for, okay, toString is pretty obvious. So what we want to do is convert the string buffer to an actual string. Or, so we can look this up, toString. We can see that toString returns a string representing the data in the sequence. And then we can search up index of. So what does index of do? Returns the index within the string at the first occurrence of the specified substring. Yeah, so this is really important. So index of is gonna find this substring, and it's gonna search our entire string buffer for another match, a match to this substring we found. So that's how we're gonna find our pattern, right? And then we do history dot substring, 0 and match length. So let's look up substring and see what it does. Substring. Substring returns a new string that contains a subsequence of characters currently contained in this character sequence. And you can click on it, and then it gives you even more data. It tells you what all these parameters do. Right? So what we can see is we're getting a substring of our history between 0 and our match length. Right? So if we go back in here, we're getting, if we want a substring 3, so this is going to be our substring. And then we're going to use our index of to search our entire string and then find a match for this substring, right? So that's kind of like the pattern matching I told you about. So index of substring gets us this string of data, and then we search the entire thing with our index of to find this part. This is the match. And then we find index, match found, index is 2, because this is the second command. Mhm. Yeah, what is it? If you have a question for me, just like, or like something you want to tell me, just send it to Melody through Zoom chat, and then Melody will get it to me. Melody will get it to me. Yeah, don't use voice, please. Anyways, if you really have something you want to tell me, just tell Melody. Okay, we're gonna go on. Yeah, index equals. So we find this entire index, right? We find our match. But what if you don't find the match, right? So let's say we've covered out all this stuff. Yeah, okay. So let's just say it's the beginning of the match and we only have these 3 lines of code. Okay? We only have these 2 lines of code. And then we look at our left to try to find a pattern. But oh no, we don't have a pattern, right? We can't find anything. So if index of doesn't find anything, let's go back to here. If index of doesn't find anything, what it's going to return is -1, right? So it's not going to return any index at all. It's going to return -1. So we check for that. So if it doesn't find anything, then it's not going to be greater than it's not going to be less than 0. Yeah. So if it returns -1, it's going to be less than 0. And as long as that keeps happening, while this while loop is going to keep on going, right? It's going to keep on looping through this while loop until we find what we're looking for. But if you keep looping through it with nothing happening, then you're going to get stuck in an infinite loop. So we have to change it. So every time we do this match length minus minus, right? And if you don't know what minus is, it basically just subtracts 1 from the variable. So every time we loop this thing, we subtract 1 from our match length, right? And I already explained what match length does. So if we don't find something that matches by 4, boom, we want to try something that matches by 3. And if we don't find 3, then we want to try 2, and so on and so forth, until we finally get to 1 and then 0. So in our example we use, if we only have forward, back, and left when we're trying to find left, we're not going to find anything, right? So it's going to go all the way down to 0. And then at that point, it's just going to exit out of the loop by itself. But index isn't going to say anything. So it doesn't find a match. Yeah. So that's so I commented out like what the meaning of this code tries to find a match for the most recent movements. If it doesn't, then it tries again with a shorter match length. Okay. And then we have integer last turns to check. I think I renamed this to make it clearer. Yeah, it's actually turns to look forward. I didn't update this part. It's updated later on the code. Okay. So we're gonna create an integer called turns to look forward. And what this is basically saying is, hey, we found the pattern, right? We found this line of code. Now, how much do we want to use? So do we think our robot's only gonna go back? So do we, th do we think it's only gonna go back, or is it gonna go left? Is it gonna go forward, or is it gonna go back and then left, or is it gonna go back then left then forward, right? So that's the turns to look forward. And how we figure that out is we find out how much time it takes our bullet to reach the enemy. So, and that's distance divided by 12.5. So if you remember, we said distance is the distance between us and the enemy. And then 12.5 is actually the amount of distance our bullet travels every time. Basically in robocode, the more power your bullet is, the slower it travels, to kind of have a trade-off. You can't be always firing power 3 bullets. And however, our robot always fires power 2.5 bullets. So, and 2.5 bullets travel at 12.5 distance every single turn. Yeah, so that's how we get this data. If you're firing a different power bullet, you need to use a different value for this number. And then one final thing to watch out for is we're dividing by number, so it might not always be a whole number, right? But we have to typecast it into whole number. This just like basically rounds it. Make sure it's a whole number, because otherwise, if we try to use it as an index, it won't work. So we're saying we want to look for like the fifth or like the fourth value of the array of an array, right? But if we say we want to look for the 4.5th element of an array, it's not going to return anything. So when you find the index of an array, it has to be a whole number. So we want to keep it as an integer. Yeah. So I've went over this concept graphic. Yeah. Every time we're going to try to find a match for the most recent length. If we don't find a match, we try again, but we decrease the length by 1. And then finally, all we have to do is use the pattern, right? Now that we have the pattern and know what the enemy is going to do, we can apply these movements to the current position to get its future position and fire. So here's our turns to look forward. We already explained this. And then do. We have this do while loop, right? And every time absolute bearing equals math.asign. Yeah. So if you don't know what arcsign is basically reverse sign. So it's like multiply is to divide as the sign is the arcsign. If you assign it, it reverses the sign. So remember how I said the sign is going to be reversed? It's right here. So we convert this angle that we've put through the sine function back into a normal angle, right? And then we use that angle to figure out, that's kind of like the difference in angle the enemy is going to go through by the time our bullet reaches that position. Yeah. So because one important thing to understand is that when you're tilting your gun, you're really all you can decide when you're firing your gun is which angle to fire at. So you want to be thinking more in angles and not in kind of directions. Yeah. And then while index. So we loop through every single value of this until we loop through a value of this equal to like basically our turns to look forward variable. Yeah. And we don't have a lot of time because it's kind of complex. So I'm just gonna kind of speed through this and I'm not gonna be able to explain everything, but I'm gonna put the code down here and you guys can email me if you have any questions. Yeah. So using patterns, yeah, and I'm just gonna explain the idea. So now that we found we found our match. So then we want to look. Well, we want to look a certain number of turns forward. So this is the match for its previous motions, and then we assume that the next values in our database are going to be what the robot's going to do next. So let's say that the distance is 24 units. That's going to take us about 2 turns. 2 turns for our bullet to travel. So we got to look ahead 2 turns. So we assume that it's going to go left 45 and forward 200. And then obviously we're going to simulate the robot going left 45, firing, moving forward 200, and then fire at that position. Obviously, as I went over before, we're using angle data and not like actual movement commands like left 45, forward 200. But the concept is the same. I just put this here so it's easier to kind of visualize. Okay, yeah, so this is the complete code. And we're going to be sending out these slides later. If we just remove our logo so it's easier to see. But we're going to be sending out these slides later, and you can just look at this code. This code is going to fit into our on-scan robot function. Yeah, so I'm going to show you guys what it looks like in an actual robot. Like this.
Byron,
Yes? Okay. I mean, yeah. If you're gonna, again, ask questions to Melody. Don't talk in voice. Okay, so I'm just gonna show you guys it in action real quick, and then you guys can look at the code later and ask me any questions you might have, because it's almost time for us to have our tournament. So I'm gonna show you pattern bot, and then I'm gonna show you something that moves in a straight pattern. So let's do, I use my first robot a lot. Let's just do my first robot. Okay, so, oh shoot. Sorry. Sorry. I had the size of the battlefield set weird for testing. Okay. So now we have it back to normal, and we can see that our pattern bot uh is accurately predicting where my first robot is gonna go, right? So it takes a while for it to get the data it needs, but then after that, you can see that it hits its shots fairly accurately, even though uh my first robot is moving back and forth. Yeah. And it doesn't just work with my first robot. So if I show you another robot uh, that goes in circles, so pretty sure there's a sample robot. Spinbot, yeah. So this robot goes in circles, right? So if you were to use something like a linear predictive shooter, you probably aren't gonna be able to hit this very well because it's gonna move in a circle instead of in a line. But once pattern bot gets the data it needs, it can pretty much accurately predict where the spin bot is going to be next, and then use that data. Yeah, so that's pattern matching. Okay, so it's about time for us to hold our tournament. So if you guys have any questions about this, you can just ask in chat, and I'll answer after 8 in our Q&A session. Or if you look at the code and you have any questions you want to ask me, you can just email me. Yeah, useful pages. I put a link into a lot of the RoboWiki pages about different types of pattern matching. Symbolic pattern matching is actually the specific type I showed you. There's a lot of other different types that you can look at. And then this pattern matching code, I changed a lot of things, but I took the basic source code from this robot called Assertive. So you can look at that as well. Okay. With that out of the way, let's go to the tournament. And actually, unfortunately, not a lot of people submitted their robots for this tournament. I mean, that's all right. But next tournament is going to be our final tournament. So we really want you guys to submit for there because we're going to do a big special event. And I'm going to explain more about that after this tournament itself. But for this tournament in Division 1, we only had 2 robots. We have Mojo Jojo the Destroyer versus Beast Mode by William. And then we have 2 dummy robots that are going to be my first robots. Wait, no, I'm sorry. They're going to be Sting Ducks because it's Division 1. And then in Division 2, we have 3 robots. It's going to be Spinner, Shepherd, and Baldy. And then there's going to be a dummy robot. This time in Division 2, it's going to be my first robot. So let's get these matches on. Let's get these matches started. So
Go sitting duck.
in Division 1, again, please don't unmute yourself unless you have like something really urgent to talk about. If you have any questions or something, you can just type them to Melody. So in Division 1, we're going to have Beast Mode, Mojo Jojo the Destroyer, and then in Sample, we're going to add in 2 Sitting Ducks. And there's going to be 3 rounds. Let's start off the battle. Okay, so right away, Beast Mode and Mojo Jojo the Destroyer are both firing at a Sitting Duck robot. So they're going to be racking up a bunch of points there. Yeah, but it seems Mojo Jojo destroyed its Sitting Duck the fastest, and now it's just Mojo Jojo versus Beast Mode. This is where the real battle begins. And both of the robots have a lot more energy than they would usually because they got a lot of energy from hitting the Sitting Duck robot. So this is gonna be quite interesting. Just speed it up a little. So far it seems that that Beast Mode isn't really hitting a lot of bullets on Mojo Jojo the Destroyer. Mojo Jojo the Destroyer is firing a lot less bullets, but they don't seem to be hitting much either. But at this rate, since Beast Mode is just firing so many more bullets, it looks like Beast Mode is gonna run out of energy before Mojo Jojo and get disabled. We're gonna see if that's really gonna happen. Yeah, it looks like it is. Beast Mode's gonna get disabled, leading to Mojo Jojo the Destroyer winning. This time, they actually go on to a Sitting Duck robot again. Both of them are firing at the same robot. Looks like Beast Mode got a few more shots off there. And now they're on to the next Sitting Duck before finally moving on to each other. Mojo Jojo seems to have the energy advantage. Is it going to be another win for Mojo Jojo the Destroyer? It looks like it. Right now, Mojo Jojo the Destroyer still has above 100 energy. Beast Mode just getting below 40. Beast Mode's missing a lot of shots here. That's causing a lot of energy to be spent. Mojo Jojo the Destroyer is firing a lot less bullets. Which actually means that it's sending less energy. Obviously, if you can hit your bullets, firing more bullets is more effective. But in Division 1, not a lot of robots can really effectively do that. So oftentimes, it seems the strategy is to just fire not as many bullets and try to make your bullets as accurate as possible. Anyways, this time, it seems that Mojo Jojo the Destroyer and Beast Mode are actually pretty even in energy. Beast Mode actually, however, does get destroyed once again, leaving Mojo Jojo the Destroyer the winner of this Division 1. With 1,210 points. Yeah. Can you fill that in, Victor? Thank you. Mojo Jojo in first place with 1,210 points. Beast Mode in second place with 664 points. And then one Sitting Duck got 100 points. The other Sitting Duck got 50 points. Okay. With that, let's move on to our Division 2 finals, which is going to be Spinner, Shepherd, Baldy, and a dummy robot. Anyways, let's remove all of these. Baldy, Spinner, Shepherd, and then go to Sample and put in my first robot. All right, let's start this battle off. Okay, let's see here right away. Shepherd and Baldy look to be having a face-off. Spinner is just spinning around. Looks relatively ignored by these two robots. My first robot is just doing its thing. But it's a battle between Shepherd and Baldy that seems to be the most intense. Oh, Shepherd is actually the winner here. But it seems that Shepherd is extremely low in energy. It's actually going to get disabled, leaving Spinner to just pick it up. Now it's just a battle between Spinner and my first robot, and it doesn't seem like either of them can really hit each other effectively. So it's going to be a battle of whichever one manages to get the most lucky shots or runs out of energy, of course. I'm just going to speed this up so this process can happen because it looks to be a really, really long final battle. Yeah. Lyndon, one piece of advice I have for your robot. It seems to survive a lot. Yeah, because the circular motion, a lot of robots use linear predictive shooting, so circle is actually really effective. But you don't have to keep your radar locked on to that one position. You can constantly keep it spinning around. So you can, even if you're moving in a circle, right, you can still fire your gun at other directions. Okay, this time, This time, Spinner and My First Robot both get taken out. It's a battle between Baldy and Shepard again. Shepard, this time, wins with a lot of energy left remaining. That was a lot quicker round, so I'm just going to slow it down a bit so you can see more of the action happening. Okay, this time, Spinner gets relatively low energy, gets taken out right away. Now, once again, it's a battle between Baldy and Shepard. Both of them literally having the same movements. This time, Baldy's going to be taken out. Oh, but My First Robot, Baldy gets disabled. And My First Robot, a lucky shot, picks it up. In Division 2, sorry, first place is going to be Shepard with a score of 728. Second place is going to be Baldy with a score of 449. Third place is going to be My First Robot with a score of 369. Fourth place is going to be Spinner with a score of 353. Good job, everybody. Can Selena explain her robot again? Why? Can you not? Oh yeah. So Selena's been talking a lot. William, if you have something prepared, yeah, you can explain the robot. But before we go into that, why isn't my robot in it? I mean, I could put it in. I thought it would be better to like just have that be like a one-time thing, because we want the tournaments to be like more of the actual robocoders, not like the instructor. Yeah, the instructor. Just to make it kind of more fair. Yeah. And then definitely for this final tournament, because we're actually gonna have prizes for our final tournament. So I'm definitely not gonna be participating in that one. So before we go over the winner's code, I'm just gonna go over our plans for a final tournament, because this is actually gonna be it's gonna take the entire RoboCode section, and it's gonna be pretty special because we're not present at the end. So the format is gonna be pretty different. So we're gonna have one mega round. So you saw earlier that I had like a big field. We're actually going to try to do that in our mega round, and we're going to add in every single robot in the division. So hopefully we can have like 7 or 8 robots all in one field at once. And we're going to all in one big field, and we're going to have them all battle it out. There's going to be 10 rounds total, but the first 3 are going to be at normal speed, and then the final 7 are going to be really sped up. So the final 7 are just to make sure that like the proceedings are more fair and there's less randomness, because the more rounds there are, the more likely it is that the actual best bots will win instead of the ones that just got lucky. But the first 3 are going to be at normal speed, so you guys can see the big battle happening. And then the top 2 robots in the mega round are going to go to the grand finals, which is going to be basically the same as we've been doing before, but it's going to be like really big grand final round between the top 2 robots. Every single finals participant is going to get a custom prize. Like, it's going to be a 3D printed robot keychain that looks exactly like the robots from Robocode. So I'm just going to show you guys. It's going to look a little bit like this. And it's going to be like a little keychain, custom 3D printed by our team members. Yeah, so it's going to be really cool. And then the top 2 of each division will actually get a custom trophy. So everybody in the grand prize will get a custom trophy that's going to be a lot bigger than the keychain. And we're going to engrave onto it the names, whatever name you want. So you can choose to engrave it with like your name or the name of the robot you put in. But it's going to be a really cool prize. And this is all because, yeah, we hope as many of you submit as possible. We know you guys haven't been submitting as much in the previous weeks, and that's okay. But this time in our like final tournament, we want as much people to submit as possible. So it's as enjoyable as possible. So everybody, just please make sure to submit a robot, even if you don't make it to the finals, you still get a prize. If you make it to the grand finals, you get like a really cool prize. Yeah. So even if you haven't really been like too serious about RoboCode, now's your chance to just make a robot and try your best. Yeah. So that was just the final tournament. If you have any questions about that, just ask them in chat or something. Ask them in chat or something, and we'll do our best to answer them. But for now, let's go over the winners robots as we always do. This time, however, to avoid any repeat winners, we're gonna be going on to like the second place robots, because I think Selena, who made Mojo Jojo, and Adrian, who made Shepard, both have talked about the robots before. We want to give as many people a chance to talk as possible. So William, I know you were in the chat. So can you tell us a little bit about your robot beast mode?
I already talked. Remember that time where I won once? I won once before.
Did you?
Yeah.
It's okay. Then is Selena here? If you guys have both talked. Sorry. Selena, are you here to talk about your robot? What happens if the robots are too far away from each other so they can't scan each other? I'm pretty sure scans have infinite range. And anyways, there's gonna be a lot. There's gonna be a lot of robots. They don't. No, they don't. So I guess it's good that I told you guys this before. So you guys will probably have to work that out yourselves. Yeah. If you guys have robocode, I'm gonna show you guys how to expand the field. So we're actually gonna be using, I'm thinking 1,500 by 1,500. So you can drag the slider, go to the rules tab and drag the slider, and I'm gonna change it to 1,500, and then you just expanded the battlefield. So you can like test it out. I have a lot of robots. A lot of these robots were just downloaded from the RoboWiki. You can go there and download some, or you can just use the sample robots and add them in and test out your own robot to see if it runs into those kind of problems. I'm pretty sure if we have enough submissions, the radar thing isn't really gonna be an issue, but you guys will have to work that out. Yeah, that's gonna be something you guys have to work out. Uh, okay. Selena, are you here? If not, William, you can just talk about your robot. Because I don't think Selena is here, or at least she's not in chat or in voice. Yeah. So can you just talk about your robot real quick? I don't think we've really talked about this. This just looks like linear predictive shooting, right?
Yeah, that's kind of linear predictor shooting. It's not necessarily linear predictor shooting. It's just like guess shooting, not really any predictive shooting. And this if loop down here is to calculate the firepower. So if the robot I just is logging onto has an energy level lower than 40, I set the fire to 2. Else I use this set fire algorithm that is in the RoboWiki.
Yeah.
That's my scan robot, and then here I put set fire because if you go back up to the run part, this is like how you make your robot to go in a circle. And I also set the velocity to random because, well, like some robots are like they predict by like how.
Yeah, velocity.
Yeah.
Yeah.
So
Something I want to add, William, is I think we went over this with Panzer. This is the old code that Adrian had, but like there's a the max velocity is like 8-ish. So your velocity is always gonna be just this max velocity. It's not gonna be changing at all.
all right. I'll fix that.
Yeah. So yeah, you probably want to change that if you really want to have a
wait,
random velocity.
Bob in the chat said max velocity is 12.
Max velocity is 12. Okay. Yeah. Thanks. Anyways, but if it's 12, like it's even if you set this like to 12 plus 12, like this 12 is always going to be here. It's not going to change. It's not going to be anything but 12, if you understand what I'm saying.
Oh yeah, okay, yeah.
Yeah.
And then at the top, you can set your color, like at the very top.
Mhm.
Yeah, right here, I just set my color.
colors.
And then I turn the radar to right positive infinity, which means like it infinitely turns. So I can like infinitely, like it just infinitely scans until it scans a robot. And then go down to
Do you do lock on? Yeah, this is lock on.
Yeah, this is lock on.
Yeah. So you have a kind of lock on. Yeah. So this is all pretty good. Yeah. It's pretty solid code for Division 1. You might want to actually try to do linear predictive shooting because I noticed both robots are missing like a lot of shots. So if you get your linear predictive shooting more accurate, or you do like some kind of pattern matching, you can hit a lot more bullets.
Oh, I thought Mojo Dojo the destroy. Oh no, it's Mojo Jojo now. Uses circular, right? It like moves in.
I can look. This looks like linear to me. Yeah, this is linear, I think. So Mojo Jojo uses linear, but it doesn't. But you go in a circle, so it's not the most accurate either. So you guys, in Division 1 should look into like targeting. I think that's what Division 1 needs to work on the most. Let's go on to Division 2. Adrian, you talked a lot. Victor, can you talk about your robot Baldi? Because you haven't put your robot in for a while. Vincent?
Okay, so I spent a lot of time working on this robot. So it's basically just a bunch of methods for dodging, targeting, and all that. So for targeting, it uses circular targeting, and for dodging, it uses stop and go.
Mm.
And then
Okay.
plus a bunch of other upgrades.
Yeah.
It just
Wait,
into
it
that.
looks like, isn't it supposed to be pattern matching? Yeah, this looks like pattern matching to me. Isn't it?
Oh yeah, I'm sorry, pattern matching. Yeah.
Yeah. Huh. Okay, so I think I know kind of like not the problem, but like an issue with your robot that uh you have this one enemy log for like all your robots and you are like everybody's data in there, right? But you can't do that and about it with multiple robots. You need one enemy log for every other robot. Do you know what I'm saying? Because if you add just like everyone's movement data into here, then when you fire on someone's robot, you don't know if your pattern is the correct one or not. Do you understand?
Okay. Yeah.
Yeah.
Thanks.
So that's something you can fix in your robot to make it more effective. Yeah, because that's what I did in my robot. In my own robot Ironclad. So it's not like the pattern matching you see here, which only has one data. I have a separate enemy, separate string for every single other enemy I see, so that I have a different data, different like kind of repository of data for everybody. Yeah, I can make a robot. Great. Again, if you're interested in RoboCode at all, please make a robot and participate because the more robots we have in our final tournament, the better. Okay, we're already over time, so if you don't have any questions, you can leave. But we're going to our after a Q&A session. We'll be staying here for around like 10 or 15 minutes. If you have any questions, just ask in chat, and we'll make sure to answer them. Good job to everybody that submitted their robots. Okay, so yeah. So the final one is next class. Yeah, that's correct. We're not gonna have like a teaching session like before. It's all gonna be this really big tournament. Yeah. Anyone have any questions? Yeah. I'd just like to add that I've seen a lot of improvement in all your robots that you guys have been submitting over time, especially in Division 1. Like in the very first time everyone submitted, everybody was basically just like a copy of my first robot, and maybe like they changed the movement directions a little or they changed the colors. But now in Division 1, like people are using like linear predictive shooting and uh, just like advanced forms of more advanced forms of shooting and moving. So it's really been nice to see all of your code become more complex. Okay. Yeah, if you have any questions, type them in chat. If not, it doesn't look like this much. So I mean, we can just end the meeting here.
Okay, if there's no more questions, then I'm gonna go ahead and end the meeting, if that's okay with you, Byron.
Yeah.
Okay.
Yeah. Bye.
Yeah.
Yeah. Thank you everybody for coming.